Reciprocal functions is a topic that you did almost completely in grade 11. In grade 11, it was probably one of the last unit that you did. And in grade 11, you looked at reciprocal functions of 1 over, and on the bottom you had a line, or 1 over, and on the bottom you had a parabola. In grade 12, where we extend it, is we say, well, let's not just stick to parabolas and lines. In grade 12, especially with our transformation unit, we looked at graphing x cubed. We know how to graph square root graphs. Now we can say, what would happen if I did 1 over any function? So did you give names to your graphs last year? Did you learn the speed bump graph and the volcano graph? The sad clown face? We make up names for whatever we think they look like. That's this topic. But now we're going to put anything underneath and look in general what happens. And probably when you learned it last year, you learned these general rules. But now we're going to look at them again and do them some more. So you have these notes. What happens? Well, first of all, your 1 over f of x graph does not mean the same as f inverse. So inverse function and 1 over f of x are not the same thing. All the 1 over f of x graph is taking any point on your original graph, which is on the bottom, and the only transformation that you're going to do is you're going to change all of your y values to 1 over y. That's the only thing that happens. In fact, I should end the lesson right now. You guys should know everything from that, and we're done. But a lot of interesting things happen when you do that. If the only thing you have to do is take your y value and go 1 over y, what's the big deal? Well, for one, as you learned last year with the sad clown face graph, it looks nothing like the original graph. When we first learned transformations, oh, you move it 3 to the left. You can see that parabola go 3 to the left, and you're like, okay, I can see what it's going to look like in the end. But with these graphs, the graphs in the end look totally different. So not only do we have to say that the only rule is that your y values change to 1 over y, we also have to look at what in particular happens with that. What are some of the patterns that happen so that we can graph these better? So we're going to go through the steps. We're going to go through them rather quickly, and then we're going to look at the examples. And by looking at the examples, we'll revisit these steps, and hopefully they make more sense. So if the only thing that has to happen is your y values have to change to 1 over y, you're going to draw your original function that's on the bottom, the f of x graph, first, so you can see what some of your y values are. Then the very first thing you're going to do is you're going to draw asymptotes. Because one of the things that you know when you're dividing by something, the bottom can't be 0. Otherwise, you're dividing by 0. So you're going to look at your f of x graph, and wherever you have x-intercepts, you're going to have non-permissible values. And what do we do with non-permissible values? Non-permissible values are either vertical asymptotes or holes if things canceled out, right? But since you just have a 1 on top, nothing's going to cancel out. And so you're always going to get vertical asymptotes wherever you have x-intercepts. That's the first thing you're going to look for. Connected to that, we're also going to draw horizontal asymptotes. So our very first step will be drawing asymptotes, horizontal ones and vertical ones. With 1 over f of x graphs, if you have a horizontal asymptote, you're going to have it at y equals 0. And you're going to have that if your original graph either goes up forever and your y values get bigger and bigger and bigger and bigger, or if your graph goes down forever and your y values get smaller and smaller and smaller and smaller. Remember that a horizontal asymptote is looking for what happens to your graph as your x values go to infinity or to negative infinity. And so if your y values get very big, so I used an example here of 10,000, or is that 100,000? That's 100,000. No, it's 10,000. Either way, that's a big number, right? And if you did 1 over that y value, what do you get? You get 1 over 10,000. That's a really small number, right? You buy a chocolate bar. You want to share it with 10,000 friends. How much does each person get? Not very much. Because when you divide it into 10,000 little pieces, you probably have more melted chocolate on your hands than you could give out to anybody, especially when it's so nice out. So it gets closer and closer to 0, and so that's how we know we're going to have a horizontal asymptote at y equals 0. So the first thing we're going to look at, non-permissible values. Do we have any x-intercepts? They're going to become vertical asymptotes. Then we're going to look at our original graph. Does it go up forever or down forever? Then we're going to have a horizontal asymptote at y equals 0. So we can kind of combine point 2 and point 3 together as asymptotes. After you've got your asymptotes, you're going to plot some points. Now, there are some points that don't change. These points are called invariant points. You don't always have to graph these points. You can if you'd like. But whenever your y value is either 1 or -1, so if I have on my original graph a y value of 1, what happens when I do 1 over that? I still get 1. So that point won't change. Same thing happens with -1. If you have -1 and you do 1 over -1, that's still -1 and doesn't change. Okay? So we're going to plot all those points. Step 4, we're going to add to that we're going to plot other points as well. So after you've got your asymptotes, you can take some of the points on your graph, and any point that you have on your graph, use that simple rule. All that's happening is your y values are changing to 1 over y. And that's what step 5. So step 4 and 5 are kind of together. We're going to just call them plotting some points. So wherever we have some important points, we take the y value and change it to 1 over y. And we'll look at what do I mean by some important points. Well, here it says look at maximums or minimums. Maybe you have some other points that are really easy to tell what the y value is. You can do any number of points and figure out where they're going to be. Once you've got some points, the final thing is you're going to draw your graph towards your asymptote. So you can show the asymptotic behavior of your graphs. Sounds like these graphs are misbehaving. Doesn't sound like good behavior, but ever happen at home? Parents tell you quit being such an asymptote? Yeah? Okay. All right. So here in the notes are set up so they have all the steps separated. What we're going to do as a class, it's so later if you wanted to go step by step and see what I would do first, what I would do second, that's how these notes are set up. What we're going to do when we go over these examples, or if you watch this video later, is we're going to do it how you would do it if this was a test or a quiz. Because you're not going to draw steps and draw each thing separately on a graph. What you're going to do is you're going to start off by graphing the function on the bottom. So that's here, but I'm going to just say, okay, x squared minus 4, that's a parabola moved down 4. So I would draw 4, label my x-intercepts, label some points that I know on there. Right? Parabola goes over 1, up 1, so if you wanted to, you could label 1, 3 as well. We've got a bunch of points on our original graph that was on the bottom. Then right beside that, we're going to do all the steps and draw a reciprocal graph. So first of all, do we have any? The first step is asymptotes. In here, that's step 2 and step 3 together, but we're going to do it all as one step. Easier to remember, asymptotes. So do we have any x-intercepts? Yes. We have an x-intercept at -2 and at 2. So take out a red pen. Asymptotes are nice to draw with a red pen. Dotted line. Label them. You have 1 at x equals -2 and 1 at x equals 2. Does our original graph have very, very large y values or very, very large negative y values? Yes. Can you see that the blue parabola goes up forever? And because it goes up forever, we're going to get an asymptote at y equals 0. Step 4 and 5 was work with your points. Do the transformation. Whatever y values you have, change to 1 over y. So what's going to happen to the point 0, -4? It's going to become 0, 1 over -4. What's going to happen to the point 1, 3? It's going to become 1 over 1, 1 over 3. If I wanted to find out some more points, because right now, do you see I only have 2 points and they're in that middle section. If I wanted to find a point in this section, well, on my original graph, do you see that you would have 3, 5? So on my green graph, I'm going to have 3, 1 over 5. And similarly, over here, I would have -3, 5. So on this graph, I would have -3, 1 over 5. I decided not to find my invariant points. I mean, if I go over from -1 and over from +1, those would be the points that don't change. But I don't have a nice x value for those because I can't figure out really easily what the x value is or label it nicely. So now that I've got some points, I can draw the asymptotic behavior. And what was this one called? That's the sad clown face. Perfect. And so we can do that all at once. What did we do to recap? We did asymptotes first, horizontal and vertical. Then 2, we plotted points. We plotted enough points until we had things in each of the sections. And then we could draw the asymptotic behavior. So this is a perfect example because it's a complete review from grade 11. Nothing was new because you had a parabola on the bottom. Here's another one with another parabola. Again, complete review. You would start off by graphing your original function. So our original function is x squared plus 1. So that's a parabola moved up 1 unit. I would have the point 0, 1. I'd have 1, 2. I'd have 2, 5, and same thing over here. Then if right beside it, I start with asymptotes. Do I have any x-intercepts? No. No x-intercepts, no vertical asymptotes. Do I have my graph go up forever or down forever? Yes, it goes up forever, so we will have an asymptote at y equals 0, and we label it. Asymptotes are done. Yes? Same thing, you would, if it went down forever, you'd have an asymptote. So if I did -x squared minus 1 and had this graph down here, I would still have that at y equals 0. Okay, so now look at our points. What's going to happen to 0, 1? It's going to stay, because 1 over 1. What's going to happen to 1, 2? It's going to become 1, 1 over 2. Same thing with negative 1. It's going to become 1 over 2. And here, now we're going to have 2 comma 1 over 5. We've got some points. We can draw what's happening. Can you see that it's going down towards your asymptote and down towards your asymptote? In fact, one of the things about reciprocals that's important to note is whatever is a minimum in a section in your regular graph becomes a maximum on your reciprocal. So the fact that 0, 1 was the minimum of this parabola, it now becomes the maximum of our other one, of the reciprocal. And what did you call this one? Speed bump. Nice. So here in example 3, we start moving into the grade 12 questions, where the function on the bottom isn't a function you graphed in grade 11, it's a function from chapter 3, transformations. So you start off by graphing the function on the bottom. Well, that function on the bottom is the square root of x plus 4. That plus 4 is a transformation. How's that going to move your square root graph? 4 to the left. So if you moved all of your original points 4 to the left, you would get negative 4 comma 0, negative 3 comma 1, 0 comma 2. What would be the next nice point? Something comma 3. 5 comma 3. Perfect. And then right beside that, we can start with our reciprocal. So first thing we're going to do, asymptotes. Do we have any x-intercepts on our original graph? Yes, we have one at negative 4. So that becomes an asymptote. Does our graph go up forever? Slowly, but yes, a square root graph does keep creeping up higher and higher and higher. So we will have an asymptote at y equals 0. Label your asymptotes with their equations. What's going to happen to negative 3 comma 1? It's going to stay negative 3 comma 1. What's going to happen to 0 comma 2? It's going to become 0 comma 1 over 2. And 5 comma 3? 5 comma 1 over 3. Show your asymptotic behavior, and we've got a graph. Ooh, new name. Boomerang. Yes. No? Okay. So all of the first 3 examples used things where you had to graph the function on the bottom. The other type of example that sometimes comes up is where the graph on the bottom is given to you. So you don't even have to do step 1. It's already graphed. Here's the graph on the bottom. So now all you have to do is beside it, and sometimes they even say do it right on top, draw the graph of the reciprocal. So we go right to, do we have any x-intercepts? Yes, we have 3 of them. We have an x-intercept at negative 1, 1 at 2, and 1 at 5. Does our graph go up forever? Well, if we look on this side, can you notice over here, no arrowhead? The graph stops at -5. But on this side, there is an arrowhead, and that arrowhead is pointing up. So this graph will have an asymptote at y equals 0. What's going to happen to our points? Well, -5, -1, that's going to stay -5, -1. -2, -1, that's going to stay -2, -1. 0, 1, well, that's going to stay 0, 1. 4, -1, that's going to stay 4, -1. And 6, 1 is going to stay 6, 1. So we have a whole bunch of points that stay the same. We have a point in each section. Is this enough to draw the graph? I'm going to say yes, but if you're unsure, you can pick some other points. For example, right here, it looks like my y value is a half. If you take the fraction of a half and you do the reciprocal, you would get, or it would be -1/2, so if I flip it, I'd get -2/1. So that would tell me at that same x value, I'm going to have -2. And if you're wondering what should happen after this point 2, -1, now you know, oops, I want to keep it green, that it goes down. Straight lines, straight horizontal lines, stay straight horizontal lines. Because all of those y values are 1. So when you do the reciprocal, all the reciprocal values are going to be the same. And they're going to stay at 1. On these ones, you will never go through the horizontal asymptote. On 1/, graphs, you won't ever go through horizontal asymptote. So in this one here, 0, 1, this is going to go up to here. In this section, you're going to go down, and here, right? So I don't know what this is. 2 sad clowns kissing. I'm not sure. Use your imagination. Not too much, hopefully. And there we have our reciprocal graph. So tomorrow in the first period, I'll give you some time to work on the homework assignment that I handed out with this.